Welcome to Module 3 of the Ethical Hacking Principle course. In this course, we will move from information gathering to active probing, teaching you how to scan networks, identify open ports, and enumerate services and system resources. You will learn advanced scan types, automated and manual vulnerability scanning, and enumeration techniques that reveal users, shares, and device details to help pinpoint real attack vectors. Scanning and enumeration. While reconnaissance helps us find the target, scanning and enumeration help us identify the doors, windows, and weak points of the building. The key difference between scanning and enumeration is the level of detail. Scanning is a broad sweep to identify hosts and open ports. Enumeration is a more detailed, in-depth process of extracting information about users, groups, network shares, and other system resources from a specific host. Learning objectives. By the end of this module, you will be able to 1. Identify and explain common scan types and when to use each. 2. Perform host discovery and port scanning using map and interpret the results. 3. Run automated vulnerability scans and assess findings for false positives and priorities. 4. Execute enumeration techniques, SMB, net bias, SNMP, to extract system details and document actionable remediation steps. Scanning fundamentals, beyond the basics. Port scanning is the most common form of scanning. It's the process of systematically checking a server for open ports to see what services are running. An open port is a potential entry point for an attacker. For a professional, it's not enough to know a port is open, you must understand how and why. The TCP three-way handshake. To understand advanced TCP scans, it's essential to first grasp the TCP three-way handshake, which establishes a connection between a client and a server. These are 3 steps to it. Step 1, SYN client sends a SYN packet to start a connection. Step 2, SYN ACK server replies with SYN ACK if the port is open. Step 3, ACK client sends ACK to confirm and complete the handshake. A full handshake creates a detectable connection. Advanced scan types and their purpose. Knowing scan types helps you choose the right method and reduce detection by IDs and firewalls. Use quieter scans when stealth matters and louder scans when you have permission and stealth is not required. There are 5 different scan types to know. 1. TCP Connect Scan, ST. 2. SYN Scan, SS. 3. Christmas or FIN and null scans, SX, SF, SN. 4. ACK scan, SA. 5. UDP scan, SU. Let's take a look at each of them. 1. TCP Connect Scan. This is the most basic and loudest scan. It performs a full TCP three-way handshake on every port. Because a full connection is established, it's easy for intrusion detection systems, IDs, to log. Use this when stealth is not a concern, such as in a controlled lab environment. 2. SYN Scan, Half-Open Scan. The most popular and default type of scan for map. It's considered stealthy because it only sends the SYN packet and receives the SYN ACK response, but does not send the final ACK packet to complete the handshake. This leaves the connection half open, making it less likely to be logged by the application or a firewall. 3. Christmas, FIN, and null scans. These scans are designed to be even stealthier. They manipulate TCP header flags in non-standard ways. According to RFC 793, if a port is closed, a server should send back a RST, reset, packet in response to these malformed packets. If a port is open, the server should ignore the packet. These scans can be highly effective at bypassing firewalls, but their effectiveness depends on the target's operating system. 4. ACK scan. This scan doesn't determine if ports are open, but instead helps map out firewall rules. It sends an ACK packet to a port. If a firewall is present and stateful, it will block the packet. If a firewall is not present or is misconfigured, the packet will get through, allowing you to map out which ports are filtered versus unfiltered. 5. UDP scan. UDP is a connectionless protocol. A UDP scan works by sending a UDP packet to a port. If the port is open, there's usually no response. If the port is closed, the target machine will send back an ICMP, port unreachable message. This makes UDP scans slower and less reliable, but necessary for services like DNS and DHCP that run on UDP. Vulnerability scanning, the role of automation. Vulnerability scanning is the automated process of scanning systems for known weaknesses. These scanners use a massive database of known exploits, weaknesses, and misconfigurations to test a target system. There are two types of vulnerability scanning. 1. Automated scanning. 2. Manual scanning. Let's explore both. Vulnerability scanning, the role of automation. Vulnerability scanning is the automated process of scanning systems for known weaknesses. These scanners use a massive database of known exploits, weaknesses, and misconfigurations to test a target system. There are two types of vulnerability scanning. 1. Automated scanning. 2. Manual scanning. Let's explore both. 2. Manual scanning. Manual vulnerability scanning is the hands-on process of inspecting systems and applications to find weaknesses that automated tools might miss. It combines targeted testing, expert analysis, and verification of scanner results to uncover logic flaws, misconfigurations, and business layer vulnerabilities. Manual scanning complements automated tools by finding logic flaws and verifying results that automation might miss. Enumeration techniques, gaining deeper insights. Enumeration takes scanning a step further, extracting detailed information from a system. Instead of just knowing a port is open, enumeration tells you what's on the other side and what it's willing to reveal. Net bias identifies computer names, users, and shared resources, tool, NBTET. SMB discovers shared folders, users, and domain info, tool, map NSE scripts. SNMP reveals device and network details if misconfigured, tool, SNMPORC. Automated and Advanced Scanning Lab. In this lab, you will use OpenVAS, a powerful open-source vulnerability scanner, to scan your Metasploitable-2 machine. These are the steps to follow. 1. Log into your Metasploitable-2 VM, and type ifconfig to get its IP address. 2. Update the system, run sudo gvm setup to install OpenVAS, GVM, note the web UI credentials it provides, start services with sudo gvm start, then open the given HTTPS address and log in. 3. In the OpenVAS web UI create a new scan task, name it, set the Metasploitable-2 IP as the target, keep the full and fast scan config, create the task, then click play to start the scan. 4. After the scan finishes, open the task report to see vulnerabilities sorted by severity, click any high severity finding for details, remediation steps, and reference IDs. Advanced Nmap Enumeration Lab. This lab demonstrates using the Nmap scripting engine to automate enumeration and extract detailed information that a basic port scan would miss. 1. Run Nmap NSE scripts in Kali to enumerate SMB shares and users on port 445, and to query SNMP information on UDP port 161 against the Metasploitable-2 VM. 2. Check SMB script output for shares and usernames useful for password attacks, and review SNMP info for uptime, device description, OS details, and exposed network interfaces. Summary. In this module, you learned how to identify system weaknesses using different scan types, map scripts for SMB and SNMP enumeration, and OpenVAS for automated vulnerability assessment, combining both manual and automated methods for accurate results.